Example 2.4. Find the area of a complex region. So in this example, we have f of x equals x squared and g of x equals 2 minus x. And we want to find the area in green. Now, you need to observe that from this region, okay, 0 to 2 right here, because that 2 is when g of x cross the x-axis. From 0 to 2, you can see that f of x is never over g of x, and g of x is never over f of x. What is f of x over? Well, you take a look at this, okay, from 0 to this area or this line, f of x is over the x-axis. So if you're really thinking about this formula, okay, from A to B, absolute value of the first function, subtract the second function. What we are talking about here is a function, okay, this is the function above, and this is the function below. So you cannot just always put f of x into the placeholder and g of x into the placeholder. You need to understand what are the placeholders are for. Now, in our case, the function that are below is the x-axis, and you can think of it as y equals 0 or h of x equals 0. So in this case, we really just need to find the area, okay, of, okay, this shape, and then we need to add the area of this shape. So that will give you an understanding of what we are doing, okay? So in order to find that, we need to find when these two functions intersect. So we need to solve when x squared will equals 2 minus x. Now this is like solving a quadratic equation. So x squared plus x minus 2 equals 0. If you don't remember how to factor, then you can use a quadratic formula. Or if it cannot be factored, you have to use a quadratic formula. But luckily, we could factor for this example. Okay, so that's two solutions, x equals -2 and x equals 1. But if you go back to the original question, the region shaded in green is from 0 to 2. So what it means is that we don't need to consider this point, okay, just x equals 1. So what it's telling us is that this is 1. That's when they intersect. So to find the area, okay, we take integral from 0 to 1. F of x is on top, so x squared. Subtract the x-axis, subtract 0. So just from 0 to 1, x squared, okay, dx. And then you need to add the next one, and the next one is from 1 to 2. And the function that is on top is 2 minus x. The function below it just x-axis, so it's 0. You think of it as subtracting 0, okay? So this is our formula. Then we use antiderivative, right? X squared is x cubed divided by 3 by the power rule, right? From 0 to 1. And then you add, this one is 2x minus x squared over 2 from 1 to 2. So you evaluate it, you will get this area is 1/3, and the next area is 1/2. So you add these together, you should get 5/6, and that is the area for this complex region.